Okay. There are 48 questions. 48 questions in this review. First question. A popular brand of pen is available in 6 colors and 4 writing tips. How many different choices of pens do you have with this brand? Fundamental counting principle. All right. This problem is an application of a fundamental counting principle. 2 steps. First step, choose the color. 6 options. Second step, choose the type of writing tip. 4 options. 6 times 4, 24. That's a straightforward one. Oh, it won't give you the immediate feedback like your homework assignments. You will have to finish everything, and once you submit the whole review, you will see which question you got right, which question you got wrong. I guarantee this is correct, by the way. Question number 2. An ice cream store sells 2 drinks in 4 sizes and 5 flavors. In how many ways can a customer order a drink? This is also an application of fundamental counting principle. So we choose the drink first and then select the size and then decide on the flavor. 2 times 4 times 3. This is a 3-part task. 2 times 4 times 3, 2 times 4 times 5, 40. 2 times 4 is 8, 8 times 5 is 40. Question number 3. In a different plan for area codes, the first digit could be any number from 3 through 8. The second digit was either 5, 6, 7, or 8, and the third digit could be any number except 5. With this plan, how many different area codes are possible? Let me get the scientific calculator. On your scratch paper, you should take some notes for this problem. This problem is not that obvious like the first 2 problems. The area code has 3 digits, right? So the task here is a 3-part task where we have 3 steps. The first step is to choose the first digit. The first digit could be any number from 3 through 8. How many options that is? You can count, right? 3, 4, 5, 6, 7, 8. That is 6 of them, right? So that's the first step. We have 6 options to put a digit in the first digit, digit of the code. Second digit was either 5 or 6 or 7 or 8, and that is 4 options. So times 4. And the third digit could be any number except 5. Except 5. It could be 0 all the way to 9. That is 10. Except 5, remove 1, so that is 9. So times 9. 24 times 9. 216. We have 216 different ways to create an error code, where we can say there are 216 possible error codes. Next. Question number 4. License plates in a particular state display 3 letters followed by 2 numbers. How many different license plates can be manufactured for this state? Same thing, fundamental counting principle, right? Fundamental counting principle. So knowing the plate has 3 letters followed by 2 numbers. So we have 5 slots to put in content, to put a content in, right? So 5 slots. The first 3 slots gonna be letters. The last 2 slots gonna be numbers. The first slot, any letter. We have 26 letters available, right? Second slot, any letters, 26. Third slot, any letters, 26. And the number 4, fourth slot is a number. The number could be 0, could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 options. The last slot also is a number, 10 options times 10. 1,775,600 possible plate. That makes sense because you want to make sure everybody has a plate, right? Otherwise, you have to extend from 5 to 6 slots. Okay, let's enter that value here. This is also fundamental counting principle. That many different license plates can be manufactured for this day. Next, question number 5. A club with 11 members is to choose 3 officers: president, vice president, secretary, treasurer. If each office is to be held by one person and no person can hold more than one office, in how many ways can those offices be filled? We went over this question before. The task here is to randomly select 3 from the 11. On your scratch paper, you should write it down, right? You need to pick 3 from the 11 available members and put them in 3 different offices. The order does matter. Since the order does matter, this is a permutation problem. Okay, just like you select 3 books from 11 books and put on a bookshelf, right? Or select 3 person from 11 available persons and put the 3 person on 3 different seats. Order matters here. Then get your TID4 calculator. You should follow along. Use your TID4 calculator. This is a permutation problem. The task is to randomly select 3 people from the 11 available people and then make an ordered arrangement of the 3 people. So C11 3. I'm sorry, I misspoke it. P stands for permutation. P11 3. We enter 11 first. Math, probability, NPR 3, 990 ways. There's many different ways. Okay, let me double check. Yep. Permutation, 990 ways can those offices be filled? Okay. Question number 6. For a segment of a radio show, a disc jockey or a DJ can play 5 records. If there are 8 records to select from, in how many ways can the program for this segment be arranged? Order matters. The DJ needs to determine which record to play first, which record to play second, and so on. So the order matters. The task here is to randomly select 5 from the 8 available records and then play them in order. So P8 5. This is a permutation problem. 8 first. 8 is the total number of records that are available. Permutation, math. 5, right? I remember you pick a 5 records. Yeah. P8 5. 6, 7, 20. 6, 7, 20. 6, 7, 20. 6,720 ways. Permutation problem. Next, question number 7. At a benefit concert, 13 bands have volunteered to perform, but there is only enough time for 7 of the bands to play. How many lineups are possible? The keyword lineup, emphasize order matters. This is also about scheduling, right? Schedule performance for performers, or play records in order. Of course, this is a permutation problem. How many people available? How many bands available? 13 available, but we only have time for 7. So P13 7 on our scratch paper, especially when the problem do not have the numerals. Instead, give the English word for the number 13, right? And 7. So you need to take notes. So this is P137, P137, 13 first, P137. It's a very large number. A million 648,640. A6 4A640 864. Yeah, but it's pretty it has a pattern actually. A64 A640. A64 A640. A64 A640. Okay. Next, question number 8. An election ballot asks voters to select 5 city commissioners from a group of 19 candidates. In how many ways can this be done? This is not a permutation problem. This is a combination problem because the order doesn't matter. The task here is to randomly select a subset. A group of 19 candidates. So on your scratch paper, you need to write down 19. We have 19 people available. What we need to do is to randomly select a subset from the 19 people. And the subset needs to have 5 people. Yeah, the subset is going to be the commission. The order of the 5 people in the subgroup does not matter. So this is a combination problem, okay? So firstly, identify this is a combination problem. Available number of people, 19. We need to select 5. So C19 5. C combination C19 5. C19 5. Do that again. C19 5. C19 5. 11,628. Okay, 11,628. That many different ways to form a subgroup and send those people in a subgroup to be the commissioners. Next, question number 9. In how many ways can a committee of 4 Democrats and 4 Republicans be formed from a group of 9 Democrats and 10 Republicans? Okay, the setting. We definitely has covered this problem in the class, but since this problem in the past has a very high rate being asked, so I'm gonna explain. And also, we are not teaching new. A lot of those problems we have already done them in the past. But I would like to spend time to talk about this. Firstly, on your scratch paper, you need to sort of settings, right? It indicates you have 9 Democrats, you have 10 Republicans, and your task is to form a committee. The committee requires 4 Democrats and 4 Republicans. And this task has 2 parts. It's a 2-part task. Firstly, you need to select 4 Democrats. Secondly, you need to select 4 Republicans. When you select the 4 Democrats, you have to select them from the available 9 Democrats. When you select the 4 Republicans, you have to select them from the 10 available Republicans, right? And then you multiply them together by the fundamental counting principle. So this problem uses both combination and the fundamental counting principle. The answer is the multiplication of C9-4 and C10-4. 9 math probability NCR C9-4 times 10 math probability NCR 4 C10-4 C9-4 times C10-4 26,460. And that's it. Question number 10. The Senate in a certain state is comprised of 53 Republicans, 44 Democrats, and 3 independents. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? Isn't this problem same with the previous problem? So on your scratch paper, you need to write down those numbers, right? 53 Republicans, 44 Democrats. You know, we don't really need this piece of information because you don't need any independent in the committee. So this is really not, doesn't matter. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? First part, randomly select 3 Republicans from the 53 available Republicans. So C53-3. 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 And second part, we're gonna randomly select 2 Democrats from the available 44 Democrats. So C44-2. C44-2. You should understand its combination, right? Yeah. So I want to just double check the multiplication symbol in the middle could be without. Let me just do it again. 53 it should be the same. You play with it and you get familiar with your calculator. Multiply 44 2. Same thing, right? Yeah. 22,160,906. Double check the entry. 22160996. Okay, very good. Next. Not bad. We have finished 10 questions. Number 11. Solve by the method of your choice. 30 people purchase raffle tickets. 3 winning tickets are selected at random. In first prize $5,000, second prize $4,500, and third prize $500. In how many different ways can the prizes be awarded? I hope you see it already. It's a permutation problem. 3 people among the 30 people gonna win the 3 prizes. Since the 3 prizes are different, order matters. Order matters, right? Like 3 different offices or 3 different seats. The order matters. The awards is different. Rewards is different. So we're gonna select 3. Randomly select 3 tickets from the 30 and make an unordered arrangement. So P permutation P33. P33 is, oh my bad, P30 33, I'm sorry, 33. P30 P30 and then 3. It's always good to double check. You never know, right? Sometimes you make a mistake unconsciously. So it's always good to double check. So in total, there are 30, yeah, here 30 people purchase raffle tickets. 30 is the total number of items, and then 3. So P 30 and then 3. 24,360. 24,360. Next. Question number 12. In how many ways can a person order one ice cream cone with 3 different flavors of ice cream if there are 16 flavors to choose from, and it matters to the person how the 3 flavors are stacked on the one cone? This sentence, it matters to the person how the 3 flavors are stacked on a cone. That means the order matters. This is a permutation problem. That is, which flavor is on the top, middle, and the bottom. So order matters, a permutation problem. Okay, permutation. How many flavors available? 16. 16 flavors available. 16 flavors available, and we need to choose the 3 from the 16. So P 16 3. P permutation 16 3. 3,360. Always double check your entry because that automatically is all that matters, right? Nobody cares what's on your scratch paper. You just need to make sure you have the correct answer in the cell in the system. Question number 13. An ice cream parlor offers 34 different flavors of ice cream. One of its items is a bowl, not a cone, a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Since it's a bowl, the order of the 3 flavors does not matter. Does not matter, okay? Because the 3 flavors in a bowl, one has to touch the other, you know. So the order does not matter. This is a combination problem. This is a combination problem. You cannot choose a order, you know, it's going to be the same. Okay, so combination problem. Available flavors 34. Choose 3. So C 34 3. 34. Sorry, do it again. C 34 3. 5,984. Double check. Question number 14. Yes, from this question we start the probability. The first 13 problems are about combination, permutation, fundamental counting principle. From this problem, number 14, we're going to start to talk about probability. This is a classical. A 12-sided die is rolled. Find the probability of rolling an even number. The set of equally likely outcomes is shown below. You know, I think we can get it, you know, for this problem. Even is a 6-sided die, not 6-sided die. It's still half, okay? The chance of getting an even number is half. The chance of getting odd number is half. Because the number of sides of the die is even. Among the 12 numbers, 2, 4, 6, 8, 10, 12, 6 numbers are even. So 6 is going to be the numerator, 12 is going to be the denominator. 6 over 12 is half. 1 over 2. Same with exam 2, it's important to read the instruction in the parentheses. It says type an integer or a simplified fraction. If you type in 0.5 decimal, it won't get it right. Okay? Because they specifically tell you to enter a simplified fraction. Next, question number 15. Also about the 12-sided die. This is the sample space. This time we need to find the probability of rolling a number less than 10. Less than 10. On your scratch paper, you are going to have a fraction. Denominator is 12. That's the total number of outcomes in the sample space. Numerator is going to be the number of outcomes that favor the result occurring. How many of them less than 10? 1 is less than 10, 2 is less than 10, so on and so on. 9 is less than 10, right? So 9 of them are less than 10, so numerator is 9. But if you leave 9 over 12 in the cell, you won't get it right because the problem tells you type an integer or a simplified fraction. We need to simplify this fraction. You can use a calculator to help you if that's a challenging for you. 9 divided by 12, go to math, fraction, 3/4, right? 3/4. So you need to enter a simplified fraction, 3/4. All right, let's see. So far, so good. Yeah, I'm recording. Let's go back. Question number 16. A fair coin is tossed 2 times in succession. The set of equally likely outcomes is head-head, head-tail, tail-head, tail-tail. Find the probability of getting at least 1 tail. Also classical. Denominator 4, because there are 4 outcomes in the sample space. Numerator, let's see how many of them has at least 1 tail. This one doesn't have any tail, right? So no, we don't count this one. This one has a 1 tail. This one has 1 tail. This one 2 tails. So 3. 3 of the 4 outcomes favor the result occurring. So the probability is 3/4. Same was earlier, but it's just coincident. Okay, it doesn't mean they all equals 3/4. It's just coincident. Question number 17. You select a family with 4 children. Male is represented by M, female is represented by F. The set of equally likely outcomes for the children's genders is shown below. Find the probability of selecting a family with at least 1 male child. All right, so do you see how many outcomes available? How many outcomes in the sample space? 4 children, right? So 2 times 2 times 2 times 2. There should be 16. Should be 16. You can count it as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the denominator is 16. On your scratch paper, you should have 16 as a denominator. Numerator, let's see how many of them has at least 1 male. At least 1 male. At least 1 M, right? At least 1 M. So actually, except this one, this outcome has all females. Except that one, everything else has at least 1 male, right? As you can see, yeah. Without the male, at least remember. Do you guys remember at least 1 is the complement of none? Is the complement of none. So the complement of this result of this event is no male, so all female. So there's only 1 outcome, no male, and the complement would have 15, right? So yeah, among the 16 outcomes, there's only 1 without a male. All other 15 outcomes at least has 1 male, so the numerator is 15. 15 over 16 is already simplified. If you are not sure, you can use the calculator. Type an integer or simplify a fraction. It is 16 over 15. Question number 18. Larry, Tyrone, Sarah, Katrina, Kim, and Maria have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. We're going to complete the following 3 parts. The first part, in how many ways can they arrive? What matters is not their names. What matters is how many of them. So 1, 2, 3, 4, 5, 6. Okay, 6 people. 6 people arrive randomly. The order, of course, matters. So this is a permutation problem. It is a full permutation. is supposed to be 6 factorial. Just double check. 1, 2, 3, 4, 5, 6. 6 factorial, or P66. 6 factorial (720). 6 factorial is 6 times 5 times 4 times 2, times 3 times 2 times 1, right? 720. Part B. In how many ways can Larry arrive first and Maria last? We can arrange Larry first. That's the only option. Yeah, or one option to arrange Larry first. One way to arrange Maria the last. But we still have 4 people, right? Because we have 6 people in total. So after we arrange Larry and Maria, we still have 4 people. Those 4 people's arrival is going to be random. So 4 factorial, 24. 4 factorial is 24. So part B, the answer is 24. Part C, find the probability that Larry will arrive first and Maria last. Part C is a probability involving permutation. The numerator, let's start with the denominator. The denominator would be the total number of ways to get the task done. The task here is to arrange the arrivals of the 6 people. The denominator would be the total number of ways to get the task done. So the denominator is 720. Denominator is 720 from part A. Numerator is the number of ways to get to make the result occurring. The result is Larry first, Maria last, right? And how many ways to make that happen? 24 different ways to make that happen. So 24 from part B is the numerator. Part C is 24 divided by 720. Part C is to use answer in part B divided by answer in part A. It says to type a fraction, simplify the fraction. So we use a calculator. Oh, not this one. TID for calculator. 24 divided by 720 has to be simplified, right? Math, fraction, 1 over 30. The probability is 1 divided by 30. That's the probability. Question number 19. In one lottery, a player wins the jackpot by matching all 5 distinct numbers drawn in any order from the white balls 1 through 42 and matching the number on the gold ball 1 through 35. If one ticket is purchased, what is the probability of winning the jackpot? This is a question that is a little bit challenging. We are going to solve the problem on my note. Now I can show you the details. Firstly, analyze the settings. It has many white balls, right? It says white balls, how many? 42 white balls. 42 white balls. And it indicates 5 of them are winning numbers. 42 minus 5, 37 of them are non-winning. Okay, in one lottery, a player wins the jackpot by matching all 5 distinct numbers from drawn in any order from in any order. That means it's going to be a combination problem. In the white ball 1 through 42, it indicates among the 42 white balls, 5 of them are winning numbers, 37 of them are non-winning numbers. To win the jackpot, the player must match all the 5 numbers on the out of the 5 winning numbers, right? And also have to match the number on the gold ball. We have a gold ball, G, gold, 35. One gold ball has the winning number. The 34 has non-winning. Okay, so that's the setting. That's the setting. This is a probability involving combination. Is a probability with combination. So the probability is K over N. N is going to be the total number of ways to get a task done. The task is to play the game. The task is to play the game, and this is a two-part game. First part, deal with the white balls. Second part, deal with the gold balls. First part, we need to select 5 white balls from the 42 available white balls, right? Randomly. We have 42 available white balls. We need to select any 5 of them. And the second part, deal with the gold balls. We need to select 1 from the 35 available gold balls. We have this many ways to, play the lottery, play the game. That's the denominator. What about the numerator? In order to win the lottery, the player has to match the 5 winning numbers on the white ball and 1 winning number on the gold balls. So suppose the player has the superpower. He knows which 5 numbers are winning numbers. He just go ahead to grab the 5 winning numbers from the available 5 winning numbers, and then go ahead to grab the 1 winning number on the gold balls. So C55, C11, that actually is just the 1. Okay, knowing it's just the 1. If you have superpower and you want to earn the jackpot, there's one way to get it done. Just one ticket, okay, one way to get it done. Grab 5 balls from 5 balls, 5 winning balls, and 1 ball from the 1 winning gold balls. That is 1. So the probability is going to have a 1 as the numerator, which is a good news, by the way. Which is good news. Why is it good news? Because it doesn't matter how big the denominator, the fraction is, the fraction is simplified. At least you do not need to worry about simplifying the fraction if the numerator is 1. What about the denominator? Denominator, we're going to have to use the calculator, right? The denominator is going to be C42 5 times C35 1. We can do that. It was 42. Yeah, 42. 42 white balls combination 5 times 35 1. Always double check your entry. 35. Yep. Okay. And the denominator is going to be this large number. 29 million. 773,380. Yeah, every 29,773,380 tickets, there's a 1 person, 1 ticket wins the jackpot. That's gonna be the denominator, okay? Numerator, you know, is gonna be 1. 1 over denominator. Double check my entry. 29,773,3. Oh, missing is 3. So 29,773, 80. Okay, doesn't have this 9. Be very careful. Be very careful. 29,773, 880. 29,773,380. Okay, very good. And that's question number 19. Question number 20. The table shows the distribution by age of a random sample of 3,650 moviegoers ages 12 to 74. If one moviegoer is randomly selected from this population, find the probability expressed as a simplified fraction that the moviegoer's age is at least 25. At least 25. This is empirical, by the way. But I mentioned that it is an empirical model, but if you switch the perspective, you can see the model as a classical. You can see you have 3,650 people in the pool, and your job is to randomly select 1 person. If you consider that experiment, that is classical, because every person has the same chance to be chosen, right? Then we can use the classical. And it says type an integer or a simplified fraction, so be very careful. Do not enter a decimal. The denominator is going to be the total number of outcomes or total number of subjects in the sample space, right? We have 3,650 people, 3650, that's the denominator. Among the 3,650 people, how many of them at least 25 years old? At least 25 years old. At least 25, that's going to be those three numbers, right? Yeah, that we can use a scientific calculator to find how many of them. So from 25 to 44, 45 to 64, 65 to 674. So all the last three rows, they are at least 25 years old. So we're going to add 1,300 with 820 and 900. That's how many people at least 25 years old. 3020. 3020. Let's use a calculator to simplify. 3020 divided by I forgot. 3020 divided by 365 0. And then go to math, fraction. Oh, okay, just to get rid of a 10, a factor 10, because both top and bottom are divisible by 10. Okay, very good. The simplified fraction, just the note doesn't have that 0. Divided by 10 here is 302 over 365. Question number 21. A single six-sided die is rolled. Find the probability of rolling an odd number or a number less than 5. Okay, this is a probability involving OR. You might remember the addition rule, right? You might remember addition rule. Okay, we are looking for a probability involving OR. Which two events? An odd number or a number less than 5? Odd number or a number less than 5. Okay? Do you remember how do we apply the addition rule? First thing to consider is to determine if the two events are disjoint. Is it possible for them to happen at the same time? Consider the sample space of rolling a six-sided die. Is it possible we roll a number that is an odd number at the same time less than 5? Odd number at the same time less than 5? Yes, right? If we roll number 1, it is odd, it's less than 5. If we roll number 3, it's odd, less than 5. So it's possible for them to occur at the same time. So they are not disjoint. The two events are not disjoint. Remember what we do? Do you remember this? Right? That's the structure of the expression we're going to evaluate for the value of the probability. Denominator, 6, right? 6 outcomes available. The first number on the top, how many of the 6 outcomes are odd? 3, we know that, right? 1, 3, 5. Second cell, how many of them, among the 6 outcomes, how many of them are less than 5? 1, 2, 3, 4. 4 of them less than 5. The last cell, the one we need to subtract, how many of the 6 outcomes, are odd and less than 5? 2 of them, right? 1 and 3, 2 of them. So the probability numerator, 3 plus 4 minus 2, that's 5. Denominator 6, so 5 over 6. 5 over 6. The probability is 5 over 6. I hope you remember that. An addition rule, we apply the addition rule when we need to find the probability involving OR. This is the not disjoint case, so we need to use that structure. Question number 22. The table shows the educational attainment of the population of a certain country, ages 25 and over. expressed in millions. Find the probability that a randomly selected person aged 25 or over has completed 4 years of high school only or is a male. Okay. This is also not disjoint. Okay. Is it possible we find a subject who is a male and at the same time complete the 4-year high school only? So we're gonna have a structure like this, all right? But I'm just going to type in a cell, and then we erase the work. Denominator, how many people available in total? 154 million. So the denominator is 154. The first number, how many of them have education 4 years high school only? 4-year high school only is this one, right? 4 only. 53 plus the second number only concern the gender. How many of them are male? Male, first row, 76, right? And minus the last number, the number we need to minus, concern both. How many of them complete a 4-year high school only at the same time as the male? 24 of them, right? Okay, give you a moment to make sense of the 4 numbers. Denominator 154, total number of items, total number of subjects in the experiment. Numerator, the first number only concern the first event. We need to find how many of the subjects complete the 4-year high school only. 4-year high school only, 53 of them. And the second number only involves a gender. So how many of them are male? 76 of them are male, right? And then minus the last number on the top that we need a minus concern both. How many of them are high school only, 4-year high school only, and male? 24 of them. Okay. This says simplify fraction, so we cannot do decimal. Denominator is 154. Numerator 53 plus 76 minus 24, 105, 105. Okay. And we're going to use the TID4 calculator to simplify. Okay, 105 divided by 154. Let me double check the entry. It's here. 105, 154. Okay, and then go to math, fraction. Simplify the result is 15 over 22. 15 over 22. Okay, 15 over 22. 15 over 22. This is supposed to be on your scratch paper. Do not leave those in the cell, okay? You only need a 15 over 22 in the cell. The rest thing that I just erased, that's supposed to be on your scratch paper. So the result is 15 over 22. Type an integer or a simplified fraction, and that's it. Question number 23. A single die is rolled. Find the odds in favor of rolling a number greater than 1. Okay, I'm gonna explain on my scratch paper. The event that is involved is to roll a number greater than 1. This is the event, a number greater than 1, bigger than 1. So let's say the event is A. Then the probability of rolling a number greater than 1 is a 6-sided die, right? 1, 2, 3, 4, 5, 6. As you can see, the denominator is going to be 6. Numerator, how many of them at least 1? Roll a number greater than 1. 5 of them greater than 1, right? So the numerator is 5. So P of A is 5 over 6. Then its complement is going to be 1 over 6 because the two probabilities need to add up to 1, right? Okay. Then what's the odds in favor of rolling a number greater than 1? Then that would be 5 over 6 to 1 over 6. we can get rid of the denominators if they have the same denominators. So the ratio would be 5 to 1. 5 to 1. The odds is 5 to 1. It's simplified. Of course, we have 5 numbers bigger than 1, and 1 number is not bigger than 1. So the odds is 5 to 1. We only have 6 numbers. Question number 24. A die is tossed. Find the odds against rolling a number greater than 2. Okay. It's good that I show you on the scratch paper, then you can see it. Against. Okay. The event involves here, the decimal space is 1, 2, 3, 4, 5, 6. The event here, let's say is A, is roll a number greater than 2. Then the probability of getting a number greater than 2, we have 4 numbers greater than 2, right? Is 4 over 6, or 2/3. And rolling a number is not greater than 2 would be 1 over 3. And very important, read the question thoroughly and carefully. The odds against, this time against, so the probability of A prime first, okay? A prime first, 1 over 3, 2, 2 over 3. Since they have the same denominator, the ratio is 1 to 2. Not 2 to 1, is 1 to 2. Be careful, this one is against. 1 to 2. Against. Half done, right? Not bad. Half done. Question number 25. What's the probability of obtaining 5 heads in a row when flipping a coin? Oh, okay. So this actually is an application of a multiplication rule. So we are finding the probability first time get a head, and second time get a head, and third time get a head, and the fourth time get a head, and the fourth time get a head, right? So it is a probability involving A and D. So we use the multiplication rule. And this is independent. This is independent. Because every time you toss a coin, you either get a head or tail, and that is a random, flip a coin, right? So this is a multiplication rule in the independent case. We just need to multiply those probabilities together. The probability of obtaining 5 heads in a row, rather in the fraction in decimal, okay. The first time get a head, 1/2. Times, okay. I use parentheses to show you. First time get a head, 1 over 2. And the second time get a head, 1 over 2. And the third time getting a head, the chance is 1 over 2. And the fourth time, of course, you can raise to the power of 5, right? Fourth time is 1 over 2 as well. Every time is 1 over 2. And the last time, the fifth time is 1 over 2. And the math fraction, 1 over 32, right? 1 over 32. 5 times in a row, so 1 over 32. I hope you see that I went over a little bit fast. It's a multiplication rule involving A and D for 5 events. Since they are independent, we just need to multiply their probabilities together. Each time getting a head, the chance is 1 over 2. All the 5 times the same thing. So we're going to multiply 1 over 2 5 times. That gives 1 over 32. And this actually is a pretty important example. Yeah, because sometimes you when you roll a die or flip a coin, you don't just do it once, you do multiple times. Question number 26. Feel free to ask questions if you have any, all right? Otherwise, I'm going to just keep going. Elizabeth brought a box of donuts to share. There are 24 donuts in the box, all identical in size, shape, and color. 3 are jelly-filled, 10 are lemon-filled, 11 are custard-filled. You randomly select a donut, eat it, and then select another donut. Find the probability of selecting a jelly-filled donut followed by a custard-filled donut. This is a probability involving A and D as well. The probability we are looking for is the probability of the first time getting a jelly-filled donut and the second time getting a custard-filled donut. Even you don't see A and D, it actually means a probability involving A and D. And then this is not independent, this is dependent because you eat the first donut. So the setting will be different when you go ahead to select the second donut. All right, so this is dependent case. But doesn't matter, you are going to multiply two fractions, okay? It's a dependent case, doesn't matter because you just need to multiply two fractions. That's the first fraction times, the second fraction. The first fraction, so think about fundamental counting principle, 2 steps, right? This is 2 steps task. First step, we need to select a jelly-filled donut. What's the chance? What's the probability? First step is to select a jelly-filled donut. What's the probability? 24 donuts in total, jelly-filled. 3 are jelly-filled, so 3 over 24. 3 over 24 is the probability of selecting a jelly-filled donut the first time. The first donut is jelly-filled. Hope you see it, okay? 24 donuts in total in the box. 3 are jelly-filled. So the chance of getting a jelly-filled donut the first time is 3 over 24. Multiply by another probability. This probability is going to be conditional. So now we have to make sure the second step to get a custard-filled donut. So when we select the second donut, we do not have 24 donuts left. We only have 23 donuts left. Among the 23 donuts that left in the box, how many of them are custard-filled? 11. Because the first time you ate a jelly-filled donut, it does not change the number of custard-filled donuts in the box. You still have 11 custard-filled donuts. So 11 over 23. And the multiplication rule means you're going to multiply the two probability fractions. Type an integer or simplify the fraction. We're going to use the calculator, okay? 3 over 24. 24. That's the first probability. Multiply by 11 over 23. That's the second probability. Multiplication rule, right? The reason I emphasize the name of the rule, because it helps you to remember you multiply. You multiply the two probabilities. Since it's a dependent case, the second probability is a conditional probability. That's all the difference. And then we're gonna simplify the fraction. 11 over 184. 11 over 184. 11 over. You don't. Those are supposed to be on scratch paper. 11 over 184. Double check. 11 over 184. Okay, that's it. Question number 27. An ice chest contains 6 cans of apple juice, 8 cans of grape juice, 4 cans of orange juice, and 2 cans of mango juice. Okay. Suppose that you reach into the container and randomly select 3 cans in succession. Find the probability of selecting a can of orange juice, then a can of mango juice, and then a can of grape juice. This is also an application of a multiplication rule. We are finding a probability involving A and D, okay? A and D. And then the case is dependent. Same with the previous problem. Firstly, I'd like to figure out how many cans in total, okay? 6 cans of apple juice, 8 cans of grape juice, 4 cans of orange juice, 2 cans of mango juice. Okay, 20 cans in total. All right, so we are going to have 3 fractions multiplied together. Oh, that's not what I mean. 3 fractions multiplied together because we involve 3 events, right? And also 3 steps. Each fraction for each step. To make the result happen, firstly, we need to make sure the first can is orange. 20 cans in total. How many orange? 4 cans of orange, so 4. So the probability getting an orange juice the first time is 4 out of 20. And then now you have an orange juice taken, right? And you give it to your friend, and your friend drank it. So you don't have you have 1 can left. In the container right now is 19 cans. And what's the probability the second time you get a mango juice? Since the first time you got an orange juice, that does not change the number of cans of mango. You still have 2 cans of mango. So 2 over 19. That's the probability of getting a mango under the condition the first time you got a orange. Okay? Now you pass the mango juice to another friend and he drank it and you lost a mango. And now the chest only have 18 cans, right? 18 cans. And what's the probability you got a grape juice from 18 cans? Grape juice, 8 cans of grape juice, so 8. You now have 18 cans in the chest. 8 of them are grape juice. So the chance of getting a grape juice is 8 over 18. That's a conditional as well, because you lose 2 cans, right? Okay, we just need to multiply the 3 probabilities together. We need to enter a simplified fraction. We're going to use that. You do the calculation, use the calculator. I need to remember the numbers. Okay, double check. Look at your look at your scratch paper. Denominator 20, 19, 18. Numerator is 4 to 8. Yeah. Multiply them together. Mass, fraction, fraction. The result is simplified fraction 8 over 855. 8 over 855. Those are supposed to be on your scratch paper. 8 over 855. Always double check. Okay, very good. Next. Question number 28. Express the following probability as a simplified fraction and as a decimal. Okay, to do 2 things. All right, so what are we looking for? If one person is selected from the population described in the table, find the probability that the person is widowed, okay, is widowed or has never married. This is a probability involving OR. However, the 2 events are disjoint. Disjoint, okay? If a person is widowed, it's not possible for the person to be never married. Widowed means married before, right? And the spouse passed away. So they are disjoint, not possible for those 2 people, 2 events occurred simultaneously. So when they are disjoint, this is the addition rule, right? Addition rule for OR, multiplication rule for A and D. So we're gonna add the 2 fractions together. Find the probability of getting, so the total number 248. Among the 248, how many of them are widowed? Widowed. Okay, 11, right? Plus the probability of randomly selected person, the person has never married, is right here. Never married is 70. Always a single. Never married is 70. 11. Okay. So the result is going to be, we are going to use a calculator, right? Eleven over 248 plus 70 over 248, right? And we're gonna use it. We'll enter decimal, right? We're gonna use the decimal later. And the math fraction 81 over 248. 81 over 248. Okay, and those are supposed to be in the scratch paper. 81 over 248. Type a integer or a decimal. Type an integer or a similar fraction. Express the probability as a decimal. Widow or never married. Round to 2 decimal places needed. So look at here, we have decimal. Round it up, right? Because 6 is bigger than 5. 0.33. 0.33. 0.4. Hold on, I already forgot. My gosh. 0.33. 33. 33. 33. 0.33. 0.33. And that's it. All right. This is addition rule. In a case the two events are disjoint, all we need to do is find the probabilities for each and add them together. All right. So this is a different problem. Okay. Looks similar though. All right. In this case, we are looking for probability OR as well. So addition rule. However, the two events are not disjoint. The two events, the first event getting a subject who is male, second event getting a subject who is married. Is it possible for the person you randomly selected be a male and married, right? So it's not disjoint. It's not disjoint. Remember what's the expression, guys? Fraction. You're gonna have one number on the bottom, 3 numbers on the top, right? It's not disjoint. So then denominator 253. Numerator, first number, only concern getting a male. Male, 119. Second number on the top, only concern getting a person who's married. Who's married, 134. Minus, remember that? Minus this number gonna concern both. How many of the people who are male and married at the same time? Married male. 66, right? 66. So that's the fraction. We just need to use the calculator to simplify. 119 plus 134 plus minus. So if you enter something wrong, what you do is you go back. You see the blinker is blinking at the sign, right? It's supposed to be negative. Supposed to minus. So 119,134 minus 66. That's the numerator. Use that to divide by the denominator. The denominator is 253. That's the decimal. And that's fraction. 17 over 23. Okay, this is supposed to be on your scratch paper again. You don't have that. You don't need that. 17 over 23. 23, sorry. 17 over 23. That's the fraction of the probability. And the decimal rounded to 2 decimal places, 0.74. 9 is bigger than 5, rounded up, 0.74. 0.74. And that's it. Yeah, two problems very similar, but one is a disjoint, the other is not disjoint. About the addition rule. Question number 30. A construction company is planning to bid on a building contract. The bid costs the company $1,100. The probability that the bid is accepted is 1/10. If the bid is accepted, the company will make $91,000 minus the cost of the bid. What's the expected value in this situation? Okay, this is about expected value. We have just recently covered expected value, right? Okay, remember we need to identify the random variable and build a 4-column table. The random variable here is also is again a profit, X here, the profit of the company. We're gonna be the company, okay? We're gonna take the perspective of a company. I think it should be enough, this space. 2, 3, 4 columns. And this outcomes. So only 2 possible outcomes, either win the bid or not win the bid, right? And for the profit, X, if they win the bid, what's the profit? We'll make 91,000 minus the cost is 1,100. 91,000 minus 1,100. That's the profit, right? And the probability of win the bid is 1/10. Okay, and that's the first row. In the case of losing the bid, the profit would be negative 1,100. When the profit is negative, it means you lose the money. You will lose the cost if you don't get a bid, right? You just the effort, the cost wouldn't a waste. So negative 1,100. The probability is 9/10. How do you know it's 9/10? Because the probabilities in this column has to add up to 1. If the chance of winning is 1/10, the chance of not winning is going to be 9/10. And the last column is going to be the product, right? So let's see what is 91,000 minus 1,100. 91,000. 1, 2, 3, minus 1,100. 89,900. 89,900. And then times 1/10. By the way, 1/10 is 0.1, okay? Times 0.1. So the product is 8,990. That's the product. And for the second row, losing case, the product definitely is negative. So I put a negative here. And the absolute value, 1,100 times 9/10. 9/10 is 0.9. 990. Negative 990. You won't forget because you already have a negative sign there, right? And the expected value would be the 2 black numbers added together. Since the second number is negative, so we're going to have 8,990 minus 990. 8,000. 8,000. Okay. Number's pretty convenient. 8 grand. The expected value in this situation is 8,000. Positive is good. Choose the statement below that best describes what this value means. Means in the long run, the construction company would expect to earn this amount of on average per bit, because the expected value is positive, right? So is again not lose. This one break even is wrong. So it's 8. Question number 31. A game is played using 1 die. If the die is rolled and it shows 5, the player wins $20. If the die shows any number other than 5, the player wins nothing. Complete part A through part B. If there is a charge of $4 to play the game, what's the game's expected value? Okay, it's also about expected value. We are the player. X is our profit. Is a variable, random variable, because depends on we win or lose, so it's random. 2, 3, 4. Outcomes XPROB products, right? So it's either win or lose. Win means you get a number. If the die is rolled and show 5, okay, you win. Other number or not 5, you lose. If it's not 5, you lose, okay? The chance of rolling a 5, 1/6. The chance of not rolling a 5, 5/6, right? If you roll a die, you get the number 5, you win. And what's your profit? You win $20. However, you pay $4 you wanted to play. So your profit is not 20, your profit is $16, okay? The player wins $20 minus the $4 cost. So $16 profit if he wins. If you lose, profit is -4. Product, 20 minus 4, 16. 16 times 1/6, 16/6. Second row, -4 times 5/6 is -10/3. Because 4 times 5 is 20. 20/6 divided by 2, divided by 2 is 10/3. It's negative, okay? Actually, hold on. I'm not going to do the reduce. I'm going to keep 20/6 here. -20/6, okay? And now we're going to add these two numbers, the two products together to have the expected value. The expected value is 16/6 plus -22/6. We're going to have a negative number, by the way, because 22 is bigger than 16. So we're going to have a negative. 22 minus 16 is 6/6. -1. Okay, what is that? This is not probability, okay, by the way, so you don't have to feel uncomfortable. Probability is a number between 0 and 1. But this is the expected value. When you play the game, you expect to lose $1. That is a lot, okay? That is a lot. Let me double check. 16/6. This is -20/6. Oh my God. My God. I'm sorry. This is not 22. Why did I do 22? -20/6. -26. So it's not $1, less than that. -20/6. -20/6. So 16/6 minus 20/6 is -4/6. That is a -3 2/3, and that is around equal to -0.67. 0.67. So 67 cents. Lose 67 cents. Okay? Be very careful. It's always good to double check. Sometimes you just make a mistake unconsciously. The expected value is going to be negative. Round to decimal, right? Round to nearest cent, so 67 cents. And in the long run, you are going to lose that much of money for each game played, right? So that's the explanation. All right, next, 32. A professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the following grouped frequency distribution table. What is the class width? Oh, okay. I mentioned you're gonna have a problem about class width, right? Class width is defined as the distance between any two consecutive lower limit. Look at it vertically. The first lower limit 50, 50. Second lower limit 55. Distance is 5. Class width is the distance between any two consecutive lower limit. From 50 to 55, 5. From 55 to 65. From 60 to 65, distance 5. So the class width is 5. Common mistake, go horizontal. 50 to 54, okay, it's 4. But that is the range of the class. It's not a class width. Class width is between classes. Well, oh, actually, yeah, you're gonna have to at least use 2 classes. So very important, do not mess up this. It's supposed to be simple problem. Do not miss this one. Question number 33. A professor had students keep the interaction number of times for a week. Okay, similar with earlier. How many students were involved in this study? Okay. We are asking, we are trying to figure out how many students are involved. 8 students report this. 11 students report 20 to 29 times. 11 students report 30 to 39 times, and so on. We have those frequencies, right? Add them all together. We have the total number of students participate in the survey. So we're going to add them together, okay? 8 plus the 2 11s make 22. 13 plus 29 plus that is 12. The last 4 gives 12. So in total 84. You know, it's always good to double check. Okay, always good to double check. So we can do that again. We do 8 plus 11 plus 11 plus 13 plus 20 plus 9 plus 3 plus 5 plus 1 plus 3. 84, yeah. You might have the experience when you confirm, okay, when you enter your routing number and the account number, when you pay something, right? They require you to type again. So that means double check. To type your account number again. So because you enter the account number at least once, then it doesn't work, right? You have to repeat to guarantee that you have the account number correct. So same thing, you do twice. If the both time get the same number, that means it's right, or very likely to be right. Question number 34. Same thing, right? But this time we need to figure out how many students had at least 70 social interactions for the week. At least 70. The last 4 frequencies, okay? This is 70 to 74 and go above. So at least 70 is 8, 7, 1, 4 added together. That's 15, that's 20. That should be an easy one, right? You should hope you see it. At least 70 social interactions. So 8 here, 7 here, that's 15. 1 here, 4 here, that's 5. 15 plus 5 is 20. That's an easy one. And this one is to create the grouped frequency distribution table. So, okay, let's do it. What time is it? We should have time. firstly, I'm going to take a picture. I'm going to show you how to take advantage of the TID4 calculator to get it done, okay? Let me take a picture of the data set. You might also notice there's a stat crunch, but unfortunately, you go to testing center, they have the lockdown browser, you won't be able to use it. So TID4 calculator is the best. So firstly, let me check how many items in this data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. That's 18, 36. 1, 2, 3, 4, 44 values. Okay, so I took a picture of the data set, and we are going to enter the 44 values in the data set. Okay, stat edit. I'm going to use L1 to clear those. Go up, clear, go down. Okay, it's going to take a little time, so bear with me. Okay, bear with me. So I go by column, then I have less chance to make a mistake. 49, 52. I go by column. Okay, 52. 49, 52, 53. 49, 52, 53. That's the first column. Second column, 57, 43, 44. Sorry, 45. 57, 43, 45. Okay. And the third column, 54, 47, 64. And let me know if I enter anything wrong. 54, 47, 64. Okay. And then we have 51, 42, 68. And then we have 59, 69, 56. And then we have 66, 48, 59, 59. And then we have 63, 61, 44. And then we have 66, 58, 68. And then we have 59, 47. And then we have 59, 66. And then we have 58, 57. And then we have 58, 66. 58, 66. And then we have 68, 69, 56, 64, 56, 64, 44, 53, 48, oops, 67, 54, 62, 52, 53. To me, is a pain. I don't know if you agree with me, but I don't really like this kind of thing. But there's no option. If you don't go through this, you have to, this actually is faster. Suppose you have a calculator. This actually is faster. You know, I'm not going to double check, but you should double check, okay? I'm very careful when I enter the values. Assume I enter the values correctly. And here in L2, you see I have L2 highlighted, right? I'm going to enter second one. L2 is going to be the same with L1. You see that? And then I'm going to highlight L2 and then assort it. Math. Hold on. So not math. We're gonna go to stat. Yeah, stat. In edit, do you see assort A? Ascending. A means ascending order. L1, second one. Close L1. Done. And then you go back stat, edit. Look at L1 is assorted. Okay, guys, L1 is assorted. L2 is the original values I enter. So L1 is sorted. So this would help us to see how many of values in each class. How many of them between 41 and 45? So this is the first value, right? First value. So 1, 2, 3, 4, 5. 5 of them. So the frequency is 5 here. How many of them between 46 to 50? 46 to 50. This one, 1, 2, 3, 4, 5, right? 5 of them. 5 of them are between the second is in the second class. Yeah, this is a lot faster than you just look at that. How many of them between 51 and 55? I need a okay, between 51 to 55. So 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay, just 8, just 8. Double check. 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. 8 is between 51 and 55. 56 to 60. 56 to 60. So go down 56 to 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no, just 11. Just 11, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I believe there are 56. Yeah, this is 11. It's 11. It's 11 of them. 61 to 65. 61 to 65. So 1, 2, 3, 4, 5. 5 of them. And then 66 to 70. 66 to 70. Oh. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. 10 of them. So let me add the frequencies together to see if I have 44. That's one way to check our entry, right? Our result. So that's 10, that's 18, 29, 34, 44. Okay, I show you the process. I think I did not make any mistakes. So that's it. Question number 36. The histogram shows the starting salaries of the graduates. The graph is based on a sample of approximately 500 recent college graduates. This is false, okay? Definitely is false. Because the total number of data items is larger. As you can see, those highest two bars already extend 600. This is more than 300. People report 51 to 55 grand starting salary, and the yellow bar here is a shy 300. So simply those two categories, those two classes already have more than 500. So definitely the total number of students is more than that, a lot more than that. Okay, so this is false. The explanation, because the total number of data items is larger. 37. Same type of problem, but this time they say the statement claims more college graduates had starting salaries in 61 to 65. This bar than 46 to 50. That's incorrect because this bar is lower than this yellow bar. Okay, this green bar, it's green, right? Not blue. Green bar, this green bar is lower than the yellow bar. So it's incorrect. Incorrect. False. Because the bar has has a lower frequency, shorter than the bar of that. That's the question. Okay, this one. Whew. Stem leaf problem. All right, so we're gonna do the same thing, same strategy. First, I'm gonna take a picture. And maybe you can, since you don't have a phone, take a picture in the exam. Maybe you can write them down on your scratch paper, right? Okay. Let's go to, this time I'm gonna use L3. I'm gonna use L3, okay? I'm gonna enter those values. 65, 61, 67. That's the first column. And then 44, 52, 35, second column. 49, 40, 38. That's the third column. And then 43, 51, 43. Okay, next 34, 29, 20. Next column 52, 39, 30. And then 46, 62, 41. And then 45, 42, 38. And then 49, 40, 34. And then 22, 37, 53. And then 54, 31, 60, 42, 58, 39, 46, 21, 62, 46. So 40 numbers, okay? I did it one time. We're supposed to double check, but I'll just skip that. You should always double check. And then I'm going to make L4 equals L3. Why do I do that? Because just want to keep the original list, you know. And then I'm going to this time sort L4. This time I'm going to sort L4, okay? I'll go to stat. Oops, that's not the way I want. Go to stat, sort ascending. I said L4, right? Second and 4. You can sort. You can sort any list. And then go back to stat, edit. Now you look at L4 is all sorted, right? It's all sorted. So 20s we have 0, 1 to 9. 0, 1 to 9 is a stem leaf plot. 0, 1 to 9. 0, 1 to 9. 0, 1 to 9 means we have 1, 20, a 21, a 22, a 29. And for 30s, we're gonna have For 30s, yeah, we're gonna have 0, 1, 2 fours, and 5. So 0, 1, 4, 4, 5, 0, 1, 4, 4, 5, and then continue. After that, 0, 1, 4, 4, 5, 7, 8, 8, 7, 8, 8, 9, 9, 7, 8, 8, 9, 9, 7, 8, 8, 9, 9, right? So 0, 1, 4, 4, 5, 7, 8, 8, 9, 9. Okay. And then for 40s, you're gonna have 0, 0, 1, 2, 2, 3, 3, 0, 0, 1, 2, 2, 3, 3, 0, 0, 2, 2, 3, 3, and 0, 0, 1, 2, 2, 3, 3, 4, 5, 6, 6, 4, 5, 6, 4, 5, 4, 5, 6, 6, 6, 4, 5, 6, 6, 6, 9, 9, 4, 5, 3 6s, 2 9s. Okay, very good. And then for 50s, we have 1, 2, 2, 3, 4, 8. Yeah, 1, 2, 2, 3, 4, 8. 2, 2, 3, 4, 8. For 6 days, oops. For 6 days, and that's the last. For 6 days, we have 0, 1, 2, 2, 5, 7. 0, 1, 2, 2, 5, 7. Always double check your entry. 0, 1, 2, 2, 5, 7. 0, 1, 2, 5, 7. Okay, finally. Right? So those are the 40 values, and we put them in the stem and leaves. What does the shape of the display reveal about the ages of the professors? Well, most of the professors are at their 30s and 40s. If you are young or younger than 30, you cannot be a college professor. That sentence is a false statement, by the way. None of the college professors live to be 70 years old. None of the college professors. Did they say that? At a university. Didn't mean they die. Maybe it's just the 40 doesn't have an older one. Doesn't mean all the professors are going to die at the 60s. The greatest number of college professors are in their 40s. Yeah, that one. Okay, find the mean for the following group of data items. Since this data set is so simple, we're going to manually find the mean. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 values. 2 plus 5 plus 7 plus 6 plus 9 plus 1 plus 9 plus 4. Double check. 23, 30, 43. Yeah, and then divide by 8. Type an integer or decimal. So 5.375. Find the mean for the following group of data items. Same thing. 1, 2, 3, 4, 5. 5 values. So sometimes it's really a scientific calculator or not an app. We don't have to use the function. We can just use the formula. 160 plus 100 plus 130 plus 100 plus 120. That's the sum. 27, 40, 50, 62. Which is this is 26, 39, 49, 59, 60. Okay, and then divided by 1, 2, 3, 4, 5. 5. 122 is the mean. Okay. Median. You can use the PID for calculator, remember? We can also use the definition, right? It really depends on your preference. For this, I can just use the manual method to get it done. Hold on a second. What happened to this? How do I cancel this? Copy. One, 2, 3, 4, 5, 6, 7, 8. 8 values. Let's sort them first. The smallest value 27, 28, 229, and then 30, 31, 33, 34, 1, 2, 3, 4, 1, 2, 3, 4. Smallest, biggest, smallest, biggest, smallest, biggest. Two values in the middle. Take the average of the two numbers, 29.5. In the middle of 29 and 30 is 29.5, right? That's going to be the median. 29.5. Find the median again. 1, 2, 3, 4, 5. 5 values. Sort them. Smallest value, 25, 225, and then 45, 55, 85. So in order, right? Smallest, biggest. Oops, sorry. Smallest, biggest, smallest, biggest. 45 is in the middle, so 45 is the median. 45 is the median. Find the mode. Okay, do you guys remember the definition of mode? The mode is a value in the data set that has the biggest frequency. Which one has the biggest frequency? 48 appears once, 52 appears once, 43 appears once, 37 appears once, 38 appears once, 33 twice. So the mode is 33. Okay, 33. And that's it. Just one mode. This one is find the mid-range. Mid-range is the average of the minimum and the maximum. Among this set of values, the smallest number is 6. Yeah, the smallest number is 6. Yeah, smallest number is 6. The biggest number is, I see 13. That is the largest number. So add the two numbers together and divide by 2. The average of the maximum and the minimum. Maximum is 13. Minimum is 6. 13 plus 6 is 19. Divided by 2 is 9.5. Okay, this question actually is very useful. It's good that we do this again. I remember we did it at least once. GPA. As a student, we're all very concerned about GPA, right? GPA is a weighted mean. And the instruction of the question tells us how to find the GPA. Firstly, we have the assigned values for each letter grade. We assign 4 for A, assign 3 for B, 2 for C, 1 for D, 0 for F. So for this student's transcript, she has 3 B's. So the value for B is 3. So 3 here, 3 here, 3 here. C is 2. Okay. And then we follow the instruction here. The GPA is calculated by multiplying the number of credit hours for a course and the number assigned to each grade. Okay? Multiply 3 by 5, 15. Multiply 3 by 4, 12. Multiply 3 by 5, 15. Multiply 2 by 5, 10. Right? And then adding these products, okay, add them together. 15, 15, 30, 40, 52. You double check. 15, 2 15 make 30. Now add another 10 is 40. 40 plus 12 is 52. And we're gonna, so that's the addition, right? Add these products. Then divide this sum by the total number of credit hours. Okay, divide this by the credit hours. Credit hours 4, 5, 5, 5, 19. The students took 19 credit hours. 5, 5, 5, 15, 15 plus 4, 19. So the GPA is 52 divided by 19. Let's see what is that. 52 divided by 19. Round, let's see how do we round it. Round to nearest hundreds. So take 2 decimal places. 6 here is bigger than 5, so round it up. 2.74. 2.74. That's the answer. 2.74. 46. Determine whether the statement true or false. The statement says measures of dispersion get smaller as the spread of data items increases. That's false. Is the opposite. False. Measures of dispersion get larger as the spread of data decrease. Okay, that one is wrong. C. Measures of dispersion get smaller as the spread of data decreases. That's supposed to be the one. And question number 47. What's this about? To find the mean and complete the following. Oh, okay. Deviations. Okay. All right. The mean. Okay. What's the mean? How many values? 1, 2, 3, 4, 5. 5 values. We're going to add the 5 values together and divide by 5. 59 plus 109 plus 84 plus 59 plus 134. Right? And then divide that by 5 because we have 5 values. The mean is 89. Means 89. Now deviation, we're going to use each value to minus the mean. 59 minus 89, negative, don't forget the sign, negative 30. 109 minus 89, that's positive, positive 20. 84 minus 89, negative 5. 59 minus 89, also negative, negative 30. 84, 89, yeah, 95. So this is negative 30. 134 minus 89 is gonna be 45. Double check. 5. Oh, 9. Oh, no. Hold on. 49. 134. Oh, hold on. I was right. 134 minus 89. 14 minus 9 is 5. 12 minus 8. 12 minus 8 is 4. Okay. All right. Those are the deviations. And what's the sum of those deviations? Let's see. Negative 30 plus 20, negative 10. Negative 10 minus 95, negative 15. Negative 15 plus negative 30, negative 45. Negative 45 plus a positive 45 is 0. The standard deviation. If you prefer use a calculator, we can do calculator, okay? 14, 10, 14, 10, 14, 10, 14, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay. We're going to use L5. 14, 10, 14, 10. Not too bad, right? Even you enter all the 8 numbers, it isn't too bad. 14, 10, 14, 10, another 14, 10, another 14, All right, so we have those 8 values. And then we go to stat, calc, one variable stat. Do you remember which list? I think it's list 5, right? We do not have frequency list, so clear. Go down, calculate. We are looking for standard deviation. S sub x. See, how do we round it? 2 decimal places. 2.14. 2.14. 2.14. So you calculate it. Double check. L5, yeah, it's L5. Okay. And last question. Last question. Find the standard deviation for the group of the data items. Okay. Oh, that's the last question already. Okay. We finished. I'm not sure if we can get 100%. If not, we just fix it. Yeah, which part we messed up? Number 31. We messed up half of the question. 31. Oh, I forgot to enter 0 point. My bad. But on my scratch paper, I do have a negative 0.7, negative 0.67, right? Negative 0.67. But I went too fast. I entered. This is a big mistake, right? So be very, very careful. Sometimes you just make a mistake without worrying of it. Okay, very good. Besides that, except that, everything's fine. Everything's fine. That's everything. So we still have 10 minutes. We're gonna do answer and the questions and answers. Let me stop the recording.